Right, one thing that you need to be able to do with linear lines in three-dimensional space is to, first of all, determine if two lines intersect. And then, if they do, find their point of intersection. Typically, in three-dimensional space, two linear lines will not intersect. In two-dimensional space, the only times they don't intersect is if you have two parallel lines. But in three-dimensional space, you can have lines which kind of do that. So one is heading off in this direction, one is heading off in this direction. And they're not parallel, but they'll never meet. It's not very often that lines meet in three-dimensional space. Okay. It's because you've got two one-dimensional objects in 3D space. Okay, so you've got kind of a dimension of freedom, if you like. So what we're going to do is we're going to look at these two lines and we're going to find their point of intersection if they intersect. Okay. So we're going to find their point of intersection if they intersect. And we're going to do that by solving them simultaneously. Now I've got the vector x, y, z here. That is often denoted by the letter r. Okay, just a shorthand notation. So whenever you see an r underlined, that means the variable vector x, y, z. That's going to equal this plus lambda times that. A second line is going to be this vector, this vector plus mu times this vector, and mu is used just to differentiate between the two parameters. Okay, they are two different lines, therefore they need two different parameters. You could use lambda 1 and lambda 2, but it's more typical to use lambda and mu if you've got two lines. Okay, so we're going to solve them simultaneously, just as we would do in two-dimensional space. We are going to equate these. So we're going to say x, y, z equals x, y, z, and we end up then with three equations in two unknowns, which doesn't always have a solution. So looking in the x direction, we're going to have 1 plus 2 lambda. That's going to equal 2 plus 3 mu. In the y direction, we've got minus 2 plus no lambda. Is going to equal 1 minus mu. And in the z direction, we've got 4 plus lambda. And that's going to equal 3 plus 2 mu. These lines intersect if the same values of lambda and mu satisfy all three of those equations. Okay. So what we're going to do is we're going to take two of those equations and solve them simultaneously. And then we will check that that pair of values satisfies the third equation. Does that make sense? We're going to take two of these equations, solve them simultaneously, and then check that that pair of values for lambda and mu satisfies the third equation. If it does satisfy the third equation, they intersect. If it doesn't, they don't.
Why don't you just solve the second one?
Solve the second one? Yes, I mean typically this would be three equations and two unknowns, but it just so happens that lambda's been removed from here because of that 0, but that's not typical. Yeah. So yeah, in this case, we can actually solve this one directly for mu, which would give us mu is 3. And then using this equation, if mu is 3, we'll get 9 plus 2 is 11, minus 1 is 10, divided by 2. We'd get that lambda is 5 using the top equation. And using the bottom equation, we would get 6 plus 3 is 9. Subtract 4, we get lambda is 5 as well. So the same value of lambda satisfies both the top and bottom equation. So therefore, these lines do intersect. And to find where they intersect, we can plug in the value of mu into this bottom one, or we can plug the value of lambda into the top one. We'll get the same coordinate. So mu into the bottom one will give us 2 plus 9, which is 11 in the x direction. 1 minus 3 which is minus 2 in the y direction, and 3 plus 6 is 9 in the z direction. We can check that by plugging in lambda as 5, so we get 1 plus 10 is 11, minus 2 plus 0 is minus 2, and 4 plus 5 is 9. So that is where they intersect. If two lines don't intersect, they are referred to as skew lines. So these are skew. So we've got, again, two equations there of different lines, and we're going to do exactly the same. So in the x direction, we're going to have minus 2 lambda is equal to 2 plus 4 mu. In the y direction, we've got 1 plus 3 lambda is equal to 2 minus 10 mu. And the z direction, we've got minus 1. We haven't. We've got 5 plus 8 lambda equals minus 1 minus 7 mu. Now, here we cannot just solve one because they've all got lambda and mu in it, so we're going to have to solve a pair. And you can use an equation solver, you can use elimination, you can use substitution, you can use a matrix method. Doesn't really matter. Exam will never ask. But the solutions to these are lambda equals minus 3 and mu equals 1. And you can check that. So 6 equals 6 and minus 8 equals minus 8. Okay, so they satisfy that. Check that these pair of values works with this bottom equation. We'll get 5 minus 24 is minus 19. And plug in mu is 1, we'll get minus 1 minus 7 is minus 8. Well, that's not true. Okay, minus 19 doesn't equal minus 8. So we've reached a false statement. Therefore, these lines do not intersect. If this was a true statement, so minus 19 equals minus 19, then they would intersect.